All right, CNT 125, Chapter 7. We just got done talking virtualization, so we're going to talk network functions virtualization. So this is virtualizing something like a firewall, router, that type of thing in your network. Again, this provides some flexibility, cost savings. You can, in some cases, install a router or firewall OS on top of VM and have that be your appliance that you need. And again, same types of pros and cons. You don't have the hardware costs. You have some energy savings, but there is the complexity of adding that into your configuration, your network, so forth. Dedicated firewalls, Fortinet, Cisco, Palo Alto Networks, so forth. They have a lot of features, a lot of capabilities. We're actually going to use a Fortinet firewall in a later lab this semester, but a software firewall, you have same type of functionality with a virtualized device that can be used in your network as part of your structure, part of your network flow, if you will. It's going to emulate a hardware firewall. It's virtualized, things like pfSense, Barracuda Next Gen Firewall, those types of things. Sometimes these are actually put on top of a Type 1 hypervisor for this to actually be that gateway device between your network and the outside. Advantage of this, quickly sometimes automate, move things from one server to another, hardware failure, your resources utilized more efficiently, like we said before. I don't have this device working maybe at 20%. I might just dial down the processing that it needs, so it's some of that process is freed up for another device. And they can be scaled up and scaled down as the need applies, instead of actually having to replace an entire hardware firewall, if you will. Disadvantage, I still need licensing. I still need interaction sometimes between the physical and virtual devices. Sometimes there's a little bit of latency to that. Some virtualization vans are uncomfortable using this virtual device in here, still kind of maybe erring on the side of a physical hardware device, but they are being used. They are in networks, and they do fulfill a need for many networks. That leads us to software-defined design networking. Software-defined networking is a centralized way to manage and control your network. So instead of having, I think I have a picture down here, yeah, instead of having a traditional network where all these devices, the network manager, network admin literally configures, consoles in, configures, consoles in, configures, consoles in, configures, we have these devices that are controlled by a controller. So I connect into the controller and I tell the network what to do, and it sends the configuration commands to all these devices. So I now have almost like a server controlling my network devices. That's what your software-defined networking is. So that leads us to, they have these different planes for infrastructure control, application management plane for managing and maintaining these networks. So here we have, this is your traditional network where I'm literally, the admin is the one doing the management work for all of this. The infrastructure is your IP, Ethernet sort of thing. Control is your upper layer protocols. Those are kind of almost the layers, if you will. With a software-defined networking controller, you actually do the control here, and it sends out the commands to the devices saying, make this happen, make this happen. This is becoming more popular as well. Not so much connecting into individual devices to configure them and manage them. We're still going to do some of the connect in and manage so we understand how these devices work. But as you get to the workplace and they're doing more of this, you at least understand, I understand what this router and switch is doing, and the controller is now telling the router and switch to do these things in my network. There's a lot of capabilities in these, and these vary depending on the manufacturer, devices, capabilities, that sort of thing. But this is becoming more normal than doing the individual consoling into each device. This leads us to our cloud computing. Cloud computing, I have an entity out there like a server that I flexibly provision for things like storage, accessing data like websites, handling clients, logging in and out, that sort of thing. That's our cloud computing. I have these professional servers that I'm flexibly provisioning as the need applies. And we're running into things like cloud storage, Google Drive, Dropbox, OneDrive, that sort of thing. Cloud hosting, things like Gmail. These are all things that are on cloud server services, if you will. Some of the big players in the game, and this is 2024, so it's not too far out of date, but Amazon Web Services, Microsoft Azure, Google Cloud, these are some of the big players. A number of years ago, I used to have you guys do Google Cloud Labs. Right now, I'm having you do Amazon Web Services Labs because they're one of the biggest players in the game right now. So to make one example maybe a little bit more real, if you do a ping to www.hack.edu, which that is pinging the web server, www, for hack.edu, you're not going to get a reply. It's going to time out because the web server is like, I'm too busy to handle your pings. I got websites to website information to hand out. However, DNS resolved www.hack.edu into this right here. And if I take a look, AmazonAWS.com. So the Hack website is being hosted Amazon Web Services. So the website for Hack, years ago used to be on a server in the Blocker building. It is now outsourced, if you will, hosted by Amazon Web Services. So this website is accessible pretty much anywhere. Fun side story, once upon a time, when Hack had pretty much all of its servers in the Blocker building, you had the web server there, D2L, in those days was called WebCT, but D2L in there, the registration system, the grade system, that sort of thing. When it came to be registration day and all the traffic was going in and out of the Blocker building, there would be so much traffic there were people trying to register for classes that the Hack website was not available. You could not load the website. So one of the first things they did was they offloaded the website data to Amazon Web Services. I'm losing track. This might be 10 years ago now. It's been quite a long while. They offloaded that traffic to there. The next thing they did when they moved from WebCT to D2L, D2L was another hosted server that is not on this campus. So those two entities, their traffic got offloaded. So the traffic coming in and out of the Blocker building for registration was not bogged down by those two entities, and vice versa. So when you go to register for classes now, you almost don't even know that this is going on because they've moved some of these pieces out and are hosted. So again, if I ping hack.edu, that's what I'm going to see. Yeah, the Hack website is hosted by Amazon Web Services, letting you know they're using one of the big players in the game. Cloud computing features include the following: on-demand services, kind of like we just said, broad network access, you can get to it from pretty much anywhere, resource pooling and metered service and rapid elasticity. Yeah, as the demand for that, let's say the website increases, you can increase the bandwidth to it and the processing to it, and as that demand goes down, it can slowly dial back. And that all handles for you. In the past, if a web server got overwhelmed, it would just shut down. Now, you can program it that it'll actually expand the processing needed and the RAM needed on it to handle that demand, but then dial it back when it's done. Really neat functions. Most of your cloud service provider are going to do virtualization. So if I host, let's say I host a website there, my wife has a website for her business that is being hosted, and it is literally a virtual machine slice of a larger physical server. So your cloud service provider has these servers, and you might get one slice of that server, especially if your business is small, and they're just going to virtualize that. They're going to give you a virtualized server to say, go ahead and put your website or whatever you need on there. And then they have maybe 2 or 3 more slices or 2 or 3 more virtual servers for other businesses doing the same type of thing. So you run into places like Amazon and Rackspace and so forth using their own virtualization for the servers that they're renting out, if you will. So you might have this going on. Okay, multiple servers and multiple things back here working for the customers. So that leads us to the different cloud service models. There's a couple different models that we can run into. The first one being on-premise. On-premise is kind of the old school way. Some things are still done this way. Some servers are still done this way, whether it be for security, availability reasons, maybe, I don't want to say proprietary, but maybe proprietary devices that you're managing in your network that, hey, it's all local, I don't need to put it outside. So in this case, you have all the equipment, all the hardware, all the operating system on site. You manage it all, you maintain it all, you're responsible for it all. The next is infrastructure as a service. So infrastructure as a service, the cloud service provider is handling kind of the networking, the server, the virtualization, and they have the basically that part on, and you would need to supply maybe the OS, the data, and the application. So you might actually put on, the Windows server that you need, or the Linux server that you need, and then maybe the website or whatever it is that you want on there that you need. So you would be providing some of this, including, like we said here, the operating system, the licensing, that sort of thing. So you're using their resources, and you're putting on what you need that's going to be handed in and out. Kind of things like cloud storage, web-hosted virtual machines, that sort of thing. The next one is your platform as a service. This is the kind of thing that they're going to provide all the hardware and the operating system, and now you start providing the data and the application. So here, web-hosted databases, web services, that sort of thing. This is the kind of thing that I have for my wife. We have rented basically the server, and it has on a Linux web server, Apache web server, and then we supply all the data and the traffic moving in and out, if you will. We provide the web page data and that sort of thing, and the traffic moving in and out. Okay, that's your platform as a service. And then last but not least, we're actually probably very familiar with this one, is your software as a service. Your software as a service, everything is getting provided. This is the kind of thing like your Google Docs and Gmail and that sort of stuff. You literally just provide the user. And this would be these kind of things as well too. So when we're dealing with Gmail, Google Docs, all that's there and ready. All we're doing is, basically providing the user. The user is actually just using that and storing files there, if you will. But everything else is there and running. And then the anything as a service could be a combination of needs for that. So you might see the XaaS, anything as a service. There's a shared responsibility model, and again, depending on, as I look back at these, here I'm a lot more responsible, here I'm a less responsible, but in the middle there is I'm responsible for some, the provider's responsible for some. So that's when they talk about a shared responsible model, you would need to know what you're responsible for, what the provider's responsible for, and kind of how to manage that. When we talk about deployment models, there can be a public, private, or community cloud. Public is just that, your Gmail, that sort of thing. Your private is strictly for your own. I maintain my own virtual servers for users in my company to use. And the community is maybe the service connecting hospitals together for, health data kind of thing, or x-ray data, that sort of thing, imaging data. That would be a community cloud between my hospitals. And I might actually have a hybrid, depending on this for the users and network, and this for the communication between our facilities. When I talk about connecting to my cloud resource, there's a couple different ways I can do this. A GUI console, command line, software development kit, or application programmable interface. This will probably be the most common. This will be the one we're going to use as we do our cloud lab. We're going to use in this case, our Amazon Web Services interface, the GUI interface, to interact with our instance of a web server that's running. I can also be using command line. Here's a Windows PowerShell running some command lines of turning an instance on or turning an instance off, that sort of thing. We'll do a little bit of this when we do our Amazon Web Services lab, just to get a feel for. And last but not least, cloud services. There are things as categorized. They're cloud services as compute, networking, storage, security. As we work with our Amazon Web Services, you'll see some of these. We'll be spinning up an instance of a web server that will be a compute capability. Networking would be, your virtual firewall kind of thing. Storage would be just a storage server, and security, again, maybe a firewall instance. Actually, networking might be a virtual switch, router kind of thing. Security might be your firewall instance, if you will. When we come back, we'll talk about our last topic of the chapter.